In this video, we are going to go over how to conduct a correlational analysis using SPSS. Just like the example given in class, sometimes you find yourselves in situations where you want to know whether two quantitative variables have a relationship, what type of relationship, the strength of the relationship, and whether or not that relationship is statistically significant. For that kind of scenario, you would want to use Pearson's correlation coefficient, or R for short. In the example given in class, we wanted to gauge the relationship between the number of ice cream bars sold for a particular month and the average temperature in Fahrenheit for that month. Obviously, number of ice cream bars sold is a quantitative variable, and temperature in Fahrenheit is also a quantitative variable. And so this example fits perfectly with Pearson's correlation coefficient. But before we can go to SPSS and conduct the analysis, there are several steps that you have to conduct. The first one is to determine which one is the independent variable and which one is the dependent variable. In our case, it's pretty simple. Temperature is the independent variable because temperature can affect how many bars of ice creams a salesman can sell in a particular day or month, but the number of ice cream bars sold cannot affect temperature. So obviously temperature is the independent variable and number of ice cream bars sold is the dependent variable. The second step is to determine whether or not the relationship is linear. Remember, Pearson's correlation coefficient only measures linear associations. So if the relationship is not linear, then you cannot use Pearson's correlation coefficient. So to do that, you have to inspect that relationship visually. You have to get a scatterplot. So here's the instructions for a scatterplot. Let's go over that using SPSS. So a scatterplot is simply a graph. So you're going to go to Graphs, Legacy Dialogs, and click on Scatter, Define. As always, the independent variable goes in the x-axis, that will be temperature, and the dependent variable goes on the y-axis. You're going to click OK, and you're going to get this scatter plot. Obviously, we see that the relationship is positive, meaning that as the temperature increases, the average number of ice cream bars sold are also increasing. Because the points, each data point is very close together, I would say this is a moderate to strong relationship. But it's linear, and for the most part, it looks linear. But to make sure, you want to double click on the figure and add. You want to come to the chart editor, and you want to add a linear line through the scatter plot. All right, close. For some reason they gave me two lines, so let's see if I can delete that one. There we go. And so when you fit a line through the scatter plot, the line seems to fit really well the general trend. So we would conclude that this is a linear relationship. So now that we're done with that, now that we determined that the relationship is linear, then you want to establish your null hypothesis and alternative hypothesis. And the null hypothesis is always going to be the same thing. The null hypothesis is always going to say that there's no correlation or association between temperature and ice cream bars sold. The alternative hypothesis is going to say that there is a correlation or association between temperature and ice cream bars sold. So to determine which one of these is correct, we're going to actually get the Pearson's correlation coefficient by going to Analyze, Then we're gonna go to correlate. Since it's two variables, we want bivariate correlations, and you can just drag in the independent dependent variable in any order. It doesn't really matter. You're gonna click OK, and when you look at the this correlation matrix, and you look at the relationship between temperature in degrees Fahrenheit and the number of ice creams, you see that the Pearson correlation coefficient is 0.88, which is a strong positive correlation. The fact that that this p-value here is 0.00, which if you were to sort of click on it, should give you it should see there were like about 10 zeros before you get to a 1. The fact that this is 0.000, which is less than 0.05, we have to reject the null hypothesis that there is no correlation, and accept the alternative hypothesis that there is a significant correlation between temperature and ice cream bars sold.